Welcome to our lesson on transformer. This is lesson 1 of the transformer series. Now what we need to do is to have the basics before we talk of transformer. The basic right from magnetic effect of electric current. That when current flows in a conductor, there is magnetic effect. And that effect we saw is magnetic field around a conductor. From there, we came to electromagnetic induction, whose application we are doing today. But in electromagnetic induction, I want you to remember what we started. We started with a wire cutting the magnetic lines of force, cutting, okay? And then we saw the galvanometer moving. Or we have a magnet and we are moving towards a magnet with a coil. And this coil is connected to a galvanometer. We were still observing a deflection. Then we build it. Instead of magnet, we just put now the application of form 2, magnetic effect of electric current. We did not use the magnet per se, but we had a simple circuit. Let me call it a primary circuit, which or whose switch, when connected, when put on, current builds from 0 to maximum. When put off, that drop from maximum to 0 brought about change in magnetic flux. So it's a two-way things in that circuit. It is switch on, off, switch on, off. Okay? But we cannot be switching on and off. We have to develop systems that are workable. Now, I'm moving from that scenario now. Which scenario? When there is change in magnetic flux on one side, induced EMF is obtained on the other side. So primarily or basically I want to talk about the input side and there is output side. So we have change in magnetic flux in the primary is now linked with the secondary coil and we get EMF in the secondary. And remember what I said, we talk of change in magnetic flux. Then the result is induced EMF before you talk of induced current. That sequence must remain. Current is as a result of EMF. So what I'm doing today is an application of electromagnetic induction. Okay? Electromagnetic induction. We've seen its basics. I've developed it from the simple understanding and keeping adding the knowledge until this level. So we wanted to make use of that. And that is made use of in transformer. Okay? And the last lesson I talked of, you see that circuit which replaces magnet and there is a conductor on the right hand side, we make use of that in induction coil. Okay? Induction coil. So let us look at definition of a transformer. A device that is used to raise or lower down the PD of an alternating current. So straight away it tells you what we deal with in transformer, the input is alternating. Direct, no. Okay? So the input here is alternating current, AC, not DC. We make use of DC where? In induction coil of ignition system of a car. 2, we are talking of increase or decrease. So it can perform two things. Okay? You can increase the PD on the secondary side, or you can reduce. So by definition, it is a device. But in this definition, you can hive a function. You can chop off a function. It is increase or decrease. What it does for you. That is its function. To increase or decrease PD of alternating current supply. There's a word supply there, okay? So we give it something, it does A, B, C, D, then it gives you something, the outcome, the product. You put in something, it handles it, then it gives you something. So that leads us to the structure. And this structure has 3 major components. We have 3 major parts, which are, we have the input side. This is just a coil. You have it wound on the soft ion, which we call the core, and then we have the output. This is what gives us 3 parts. We have the input, we have the core, and we have the output. Okay? Remember, the last lesson I told you 3 things. The induced EMF in the secondary can be increased by winding the primary and secondary coils on a soft iron rod. A rod, just a rod, okay? So you have a coil one side, then you have another coil the other side. So these two, the last lesson I drew, there was no core. But I told you, if you put now a soft iron in the 2 coils, primary and secondary, you will be able to increase the EMF. Do you remember that? I said it. Then the second thing is winding it on a soft ring, whose major aim is to link the ring, to link the primary flux with the secondary. You hear, it may not look a ring, but we will still get, okay? We still get the idea here. So this is the input. Now I am adding something, that the input we have alternating PD. Okay? Then the output, I can add something here this way. I put here and then I put here. Can say that. So we are inputting an alternating current here. This alternating current will bring about magnetism in this coil. Okay? The magnetism I'm talking about is basically magnetic field. That magnetic field, remember, lines of force will be concentrated. So you have them here. It links. You can draw as many as you wish. See? Magnetic flux of primary is linked with the secondary by this core. Okay? By this core. Now, this secondary coil will have induced EMF. induced EMF, please, is the driving force of electrons to go round. Okay, driving force, pushing. It is the one which pushes electrons. Go, 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 go. Then the electrons, once they flow in a circuit, we say it is current. It's a push. In quotes, a push. Electromotive force, a push. That happens because of the change in magnetic flux of the primary. The core links that change with the secondary. Then secondary gives you something. So this is the consumer of our product, if I may say so. This is the giver, the initiator of this process. This alternating PD. Initiator of the process is this. Then facilitator is the one connecting primary and secondary. The primary winding are not connected directly to the secondary. You can see in the diagram. So our transformer now, if it is 100% efficient, then whatever we gave it is whatever it will give out. That is the assumption we are going to use in the next lesson. For now, I think I have introduced what is a transformer, what is the function, what is the component. In the function here, you can put in a bracket, when we increase, we step up. That's another language. Or when we decrease the PD, it is called step down. So the transformer can either step up or step down the voltage. That's why here you can still save. If you write primary voltage here, you can still have this, and then you have positive, negative, primary voltage. Then you can also do here, this is secondary voltage. Okay, so we are going to see how can you make it more or how can you make it decrease. Okay, so that is what we have. This is what we have, the major parts. The input part, which we call primary. This is the primary side. Then we have the core, okay? And then we have the secondary side. So we can have here secondary. So the letters S and the letter P, when I use them, they should ring to you. This is the primary side, this is the secondary. This is a consumer, is a device that will be using the product we are getting from the transformer. Okay? There is something, because we are not doing this, for the sake of it. Okay? We are doing the right thing. So, next time we shall look at efficiency of transformer, the relationship between the voltage and the turns, and how question can be calculated. Bye bye, subscribe, you get next lesson.